So hello students, today we see some problems in stoichiometry. Okay, so first see what volume of 0.1 m. M means we know that molarity of KMnO4 is required to oxidize 100 milliliter of 0.2 m ferrous sulfate in acidic medium. So actually మనకి number of moles తో మనం ప్రాబ్లం చేయాలంటే we have to know the total reaction తీసుకొని మనం after balancing that reaction we compare the number of moles, but we also one another concept that is comparing the milli equivalents. In the introduction class we discussed that there are two methods to do the stoichiometric problems: comparing the moles and equalizing the milli equivalents. Means here we are able to calculate it in terms of milli equivalents. Okay, so milli equivalents, so what is the easy అంటే మన total reaction find out చేయాల్సిన అవసరం లేదు. Okay, so see the reaction. Sorry, this I will explain the problem. So I have to find out what volume of 0.1 m KMnO4 is required to oxidize 100 milliliter of 0.2 m FeSO4. Like 0.2 molarity ఉన్న 100 milliliter of total solution ni oxidize చేయాలి. So అంటే FeSO4 should be oxidized. So, and it is given in acidic medium. We know what is the change of KMnO4 in acidic medium. So KMnO4 lo which part is changed? MnO4 minus becomes Mn plus 2. We know in acidic medium permanganate ion changed to manganese ion. So what is the change in the oxidation number? Plus 5 directly plus 2. So what is the change? Sorry. Here, what is the oxidation number of manganese? That is plus 7. Okay. How you got plus 7 means x minus 8 is equal to minus 1. X equals 7. You can direct to plus 3 ichadu. So plus 7 to plus 2 change. So it undergoes reduction. So reduction, how many electrons gaining? 5 electrons. So 5 electron. So what is the n factor? Here n factor for this reaction is 5. Already we know how to calculate the number of electrons. So it is reduced. So it itself it is reduced means it works as the oxidizing agent. So it then oxidization it oxidizes the ferrous sulfate. So ikkada ferrous sulfate lo oxidize ki undergoes. So oxidize lo involve ayye oxidation lo involve ayye part ఏంటిది Fe plus 2 is oxidized to Fe plus 3. So ferrous sulfate lo Fe plus 2 becomes Fe plus 3. So your oxidation number directly plus 2 plus 3. So when it loses one electron it becomes like this. So losing electrons come on right side asta. So therefore what is n factor? So n factor equal to 5. So this MnO4 minus oxidizes this ferrous into ferric. Means itself MnO4 minus itself it is undergoes reduction and it is undergoes Fe plus 2 undergoes oxidation. Okay. So because మనం ఫైండ్ అవుట్ చేయాల్సింది ఏంటంటే సో మనకి పర్ఫెక్ట్ వాల్యూస్ ఇచ్చి మనకి 0.2 m మొలారిటీ ఇచ్చిన Fe plus 2 కి వాల్యూని ఇచ్చిండు. ఓకే. సో యాక్చువల్గా బట్ వాట్ ఈస్ ద కంపారబుల్ ఫ్యాక్టర్? ద కంపారిజన్ ఫ్యాక్టర్ ఏంటంటే మిల్లీ ఈక్వివలెన్స్. సో ఆల్రెడీ వీ నో మిల్లీ ఈక్వివలెన్స్ మీన్స్ so what is milli equivalence? Milli equivalence means normality into volume in milliliter. It is milli equivalence. Okay, but two reactants perfect ga complete ga react avvalante two reactants for example x comma y ee rendu perfect ga react avvalante okala perfect ga react ayini ante what is the step we can take is milli equivalence of both species are equal. Milli equivalence of x equal milli equivalence of 5. Already we In introduction class we discussed that milli equivalent of oxidant is equal to milli equivalent of reductant. In neutralization reaction, milli equivalence of acid equal to milli equivalence of base. ఇది ఇక్కడ ఆక్సిడెంట్ రిడక్టెంట్ కాబట్టి మనం సో మిల్లీ ఈక్వలెన్స్ ఆఫ్ బోత్ కాంపౌండ్స్ ఈక్వల్ చేయాలి. So here MnO4 minus is exactly equal to 100% equal to Fe plus 2. Both are reacting part. So రెండు reactants ఇది MnO4 minus react with Fe plus 2. So perfect గా reaction complete అవ్వాలంటే so their milli equivalents should be equal. So therefore milli equivalents of MnO4 minus are equal to milli equivalence of Fe plus 2. Milli equivalence means we know the formula normality into volume. Actually we don't know its normality. Normality into its volume is given how much? Sorry, its normality. Let's think of N1 అనుకుందాం. Okay, N1 V1 equals say N2 V2. 1 2 అవసరం మనకి normality into volume, normality into volume. So here normality is given, not given, sorry. For potassium per mole it is given molarity 0.1 m molarity in potassium per mole. So already we know what is the relation between normality and molarity. So normality is equal to molarity into n factor. So ఈ relation perfect గా idea ఉండాలి. Okay. So for normality లేదు కాబట్టి we know the molarity. What is the molarity? 0.1 m. What is n factor? Already we calculated 5. What is the value? We have to find this. So ఈ value find out channel. So what is N2? Its normality is given. Its normal. It is also given in terms of molarity. 0.2 m. Molarity into n factor just 1. What its value? The volume of ferrous sulfide solution neutralized 100 milliliter. Okay, therefore value of MnO4 minus V is nothing but KMnO4. Okay. Okay. The total we will get 40. Okay. This means it need 40 milliliter of potassium permanganate. So at last you can write a sentence. Actually you have to write compulsory. So at last you have to write it need 40 milliliter of potassium permanganate to react. Nothing but to oxidize the 100 milliliter of 0.1 m KMnO4 solution. Okay, write the step neatly. So here we can write finally is required. See one more problem. So what value of 0.2 m potassium dichromate is required? Same model. To oxidize 50 milliliter of 0.3 m sodium oxalate in acidic medium. Okay, so again it is also same model. So intaku reaction was between potassium permanganate and ferrous sulfate. Here the reaction is potassium dichromate and oxalate. So already we know, so milli equal in terms of milli equivalent just the total reaction mentioned as nostrum level. So that is the best thing using the milli equivalent concept in the stoichiometric calculations. So it is given acidic medium. So oxidize 50 ml of K2Cr2O7, we know that good oxidizing agent. So it oxidizes oxalate. Okay, so kabatti we can compare the milli equivalents of this oxidant, sorry, it's oxidizing oxidant equal to reductant. So first we have to find out the n factor. So n factor telokona mana problem cheyalem. So how to calculate the n factor? We have to know the change. Cr2O7 minus 2. So already how it changes, already in the last two sessions we discussed what is the changes of different compounds or ions in different mediums. In acidic medium we know that K2Cr2O7 works as oxidizing agent, means itself it is reduced. So how many electrons? Its oxidation number we know it's plus 6. 2 chromiums are in plus 6, 2 chromiums are plus 3. So 1 chromium plus 6 to plus 3, second chromium also plus 6 to plus 3. So total 6 electrons. Okay. So plus 6 to plus 3 and then say there is a changing of 6 electrons. So therefore what is the n factor? 6. So it itself it is reduced. So it then oxidizes the oxalate. So how its reaction, we know that C2O4 minus 2 always is oxidized to carbon dioxide. So again 2. What is the number of electrons? What is the oxidation number of carbon? 2x. 3. Here oxidation number x. So plus 4. So like these two carbons are changed. So 3 to 4. The second carbon also changed from 3 to 4. So what is the change? How many electrons? Losing of how many electrons? Totally 2 electrons. So therefore here n factor. So if you are very perfect in the knowing the n factor, so directly we can do the problem. So now we got the n factors. After n factors, so oxidant, reductant, but the step we can write the milli equivalents of potassium dichromate Cr2O7 minus 2. It's nothing but milli equivalents of oxalate C2O4 minus 2. So we know that milli equivalents means normality into volume. So normality, say it is N1V1, it is N2V2. Okay. So what is N1? So we don't know the N1, it is given only molarity each. So molarity step. So molarity in normality equal molarity into n factor. So what is n factor for this? Just now we calculated that is 6 electrons. Into what is the value? We have to find that. So N2, it's also given 0.3, it's n factor. What is n factor? It's whatever you got 2 electrons here. V2 50 milliliter. To 6, okay. So 1 get cancelled. The total is 50 milliliters. So it is given how much test weight? So what is the volume? So 0.50 here 2 is there. So 25 milliliters. So therefore it need a 25 milliliter of potassium dichromate. Is required. Okay. So next see one more problem. So it is somewhat difficult compared to the first and second problems. Here 5 milliliter solution of hydrogen peroxide liberates 1.27 gram of iodine from an acidified, means it is given in acidic medium, acidified potassium iodide solution. So I have to find what is the molarity. What is the molarity of a H2O2 solution, hydrogen peroxide. So actually, so it is a total different. So same model మనం follow అవుతాం, but ఇక్కడ మనకి the reaction part and a product part is also given. Okay, so ఇప్పుడు దాకా మనం చేసిన first two examples లో only reactants are given, that is one oxidant and one reductant. So first problem the potassium permanganate and ferrous sulfate, okay, redox reaction. So in the second problem there is a potassium dichromate, sodium oxalate, but here hydrogen peroxide react with some of Ka solution. So there is no actually reactant change మనకి just listen carefully. The hydrogen peroxide react with potassium iodide. కాబట్టి మనం జనరల్గా ఏం కంపేర్ చేస్తాం, ఇప్పుడు చేసిన ప్రాబ్లమ్స్ బేస్ చేసుకుంటే ఆ టూ రియాక్టెంట్స్ కంపేర్ చేస్తాం. సో ఇక్కడ మిల్లీ ఈక్వలెన్స్ ఆఫ్ హైడ్రోజన్ పెరాక్సైడ్ is equal to milli equivalence of potassium iodide, but there is no details given about potassium iodide. Okay, so కాబట్టి మనం potassium iodide details తీసుకొని problem, actually there is no details of potassium iodide are there, but దేని డీటెయిల్స్ ఇచ్చినట్టే ఈ రెండు రియాక్ట్ అయితే వచ్చే ప్రోడక్ట్ ఏంటంటే అయోడిన్. సో Ki యాక్చువల్గా Ki లో మనకి అయోడిన్ పొజిషన్ I minus. This I minus is oxidized. I minus is oxidized to iodine. It is oxidized by hydrogen peroxide. Means what is oxidant? Hydrogen peroxide is the oxidant. కాబట్టి milli equivalence of oxidant equal to milli equal of reductant అంటే ఇది వస్తుంది, కానీ దీని డీటెయిల్స్ లేదు. సో దీని నుంచి ఫామ్ అయిన కాంపోనెంట్ ఇది అయోడిన్. అంటే ఇక్కడ మిల్లీ ఈక్వలెన్స్ మనం ప్రోడక్ట్స్తో కూడా ఈక్వల్ చేయొచ్చు. ఓకే, ఒరిజినల్గా మనం సో ఇట్స్ వెరీ ఇంపార్టెంట్ స్టెప్. సో డైరెక్ట్ ఓన్లీ టూ రియాక్టెంట్స్ ఇస్తే మనకి ఫర్ ఎక్స్ వై టూ రియాక్టెంట్స్ తీసుకుంటే మిల్లీ ఈక్వలెంట్ ఆఫ్ ఎక్స్ ఈజ్ ఈక్వల్ మిల్లీ ఈక్వలెంట్ ఆఫ్ వై తీసుకుంటాం. బట్ ఇక్కడ వన్ రియాక్టెంట్కి నో డీటెయిల్స్ ఆర్ గివెన్, కానీ ప్రోడక్ట్ డీటెయిల్స్ ఇచ్చిండు. సో ఇదే రియాక్టెంట్ నుంచి మనకు వచ్చే ప్రోడక్ట్ ఐదు, దీని డీటెయిల్స్ ఇచ్చింది కాబట్టి హియర్ సో వీ కెన్ రైట్ ద మిల్లీ ఈక్వలెన్స్ ఆఫ్ హైడ్రోజన్ పెరాక్సైడ్. సో యాక్చువల్గా ఏం రాస్తే మనం మిల్లీ ఈక్వలెన్స్ ఆఫ్ Ki, but it is not given. So it is also observed that milli equivalence of products are also same. ఓకే. సో బోత్ ఆర్ టోటల్ సింగిల్ రియాక్షన్ కాబట్టి మనం మిల్లీ ఈక్వలెన్స్ ఆఫ్ రియాక్టెంట్స్ని మిల్లీ ఈక్వలెంట్ ఆఫ్ ప్రోడక్ట్ని కూడా కంపేర్ చేయొచ్చు. ఓకే. సో ఇక్కడ మనకి సో ఇంతవరకు ఇచ్చే ప్రాబ్లం పర్ఫెక్ట్ ఉండేది, జస్ట్ లైక్ లాస్ట్ ప్రాబ్లమ్స్ మోడల్. బట్ హియర్ దిస్ పార్ట్ ఈజ్ నాట్ గివెన్. సో ఈ పార్ట్ ఇవ్వలేదు కాబట్టి సో వీ క్యాన్ కంపేర్ milli equivalence of hydrogen peroxide is exactly equal to milli equivalence of I2. So ఇది ద్వారా ఈక్వల్ చేయాల్సింది. So what is the first we see? What is the H2O2 reaction? So hydrogen peroxide reaction. So what is the hydrogen peroxide reaction? The last problem said is not there. Actually, so it becomes like this. Okay. So here hydrogen peroxide, the two oxygens ఇక్కడ -1 condition లో ఉంటాయి peroxides లో. The -1 condition becomes -2. మన ఆక్సిజన్స్ మనం చెక్ చేస్తున్నాం కాబట్టి just balancing that. ఇక్కడ oxygen oxidation number -1. So 2 oxygens kabatti, so -1 comma -1, and here it becomes -2 comma -2. 2 oxygens are like that. Hydrogens edu balance cheyalante manam ikkada compare chesedi change unna part. Ikkada oxidation number hydrogen +1 kabatti, so akkada mana n factor find out cheyadaniki దేని oxidation number change avuddu danne compare chestam, danne balance chesi compare chestam. So ikkada -1 becomes -2. When it's possible? By taking 2 electrons. So therefore, what is n factor for hydrogen peroxide? Hydrogen peroxide n factor is 2. So in the last 2 days calculation man hydrogen peroxide rale. So konni manaki separate direct compounds vastayi. From now onwards we have to remember this reaction. Means the hydrogen peroxide n factor and acidic medium is 2. But what is the iodine? So iodine, from where iodine is formed? Iodine is formed from potassium iodide. Here I minus becomes I2. So I2 0 molecules. Iodines 2 iodines. So what is n factor? Again here also n factor equal to 2. But here one important thing is we calculated it for 2 iodines. Okay, I2. So apply them in equation 1. Milli equivalence means normality. We know N1 V1 equal to N2 V2. So what is the normality of hydrogen peroxide is given? So it is not given, just volume is given. So N1 and other value 5 milliliter. What is N2? So normality of iodide is given. So ఇక్కడ ఇంపార్టెంట్ మనకి అయోడిన్కి నార్మాలిటీ ఇవ్వలేదు, మొలారిటీ ఇవ్వలేదు. నో నార్మాలిటీ, దెర్ ఈస్ నో మొలారిటీ ఈస్ గివెన్. సో కాబట్టి మనం డైరెక్ట్గా నార్మాలిటీ ఫార్ములా బేస్ చేసుకొని చేద్దాం, బికాజ్ వెయిట్ ఇచ్చింది మనకి. సో నార్మాలిటీ ఫార్ములా వి నో దట్ నార్మాలిటీ ఈజ్ ఈక్వల్ వెయిట్ బై ఈక్వలెంట్ వెయిట్ ఇంటూ 1000 బై వాల్యూమ్ ఇన్ మిల్లీలీటర్. సో ఇట్ ఈస్ అ నార్మాలిటీ ఫార్ములా, వి నో దట్. So ఇక్కడ నార్మాలిటీ మనం సబ్స్టిట్యూట్ చేద్దాం. వెయిట్ హౌ మచ్ ఇట్ ఈస్ గివెన్, హౌ మచ్ 1.27 weight by what is equivalent weight? So equivalent weight ante, so we know that, so formula weight by n factor. So ikkada formula weight in manaki, so I2 not I, here there is a form we are comparing with I2 not for I. So just iodine aitena 127. So ikkada formula weight mention chesi andike just iodine raste 127 rase ఛాయిస్ ఉండే. సో ఇక్కడ molecular weight iodine in the 127 plus 127, 2 iodines are there. So 127 into 2. What is the n factor for this I2 formation? I2 formation and 2. So into 1000 by volume we don't know. So one volume gets generated. So volume in say milliliter. So big bracket. Next again V2. So what is the V2? V2 is the volume of again the volume of iodine in terms of milliliters. So automatically they get cancelled. So kabatti so ఈ value milliliters volume ఇవ్వలేదు కాబట్టి there is no problem. Even మనకు వాల్యూమ్ ఇవ్వకుండా కూడా ప్రాబ్లం లేదు, బికాస్ వాల్యూమ్ ఎట్లా క్యాన్సిల్ అయిపోతాయి. సో నౌ రైట్ ద స్టెప్స్ to also get cancelled. So what is n1? So n1 is 1.27. So make it also 127. So it becomes 127 into 10. Okay, 10 is there. So finally, so normality equals to 2 means that the normality of hydrogen peroxide is equal to 2. So I think the question is we have to find the molarity. The question is the calculation of molarity. So again with the help of relation. So normality is equal to molarity into n factor. N factor means number of electrons. The basis kone so molarity find out this done. So it implies molarity is equal to normality by n factor. Normality 2. What is the n factor for hydrogen peroxide? 2 electron. That is 1. So the molarity of hydrogen peroxide solution is 1m. Okay. So we see one more problem. So actually these problems are looking very easy, but if in exams it become very confusing to compare the milli equivalents. So I have to practice at least 2 to 3 times. See one more problem today. There is how many moles of so it is given in terms of moles. So how many moles of potassium permanganate will be required to react completely with 1 mole of potassium oxalate, again in acidic medium. So actually so in general in terms of molarity, so in terms of volumes so we can simply equalize the milli equivalents. So there is no particular information is given, just it is given in terms of moles. So the moles of K2C2O4 is given, so I have to find the moles of KMnO4. Okay, so total both are reactant. Potassium permanganate is what? It's oxidizing agent. It's oxidizing agent, and we know that K2C2O4 is a reducing agent. So it undergoes reduction, it undergoes oxidation. Just now in the second problem, I think we calculated MnO4 minus becomes Mn plus 2 n factor 5, C2O4 minus becomes 2CO2, n factor equal to 2. సో ఇక్కడ మనం డైరెక్ట్గా మోల్స్లో క్యాలిక్యులేట్ చేయాల్సినప్పుడు సో మన ఎన్ ఫ్యాక్టర్ ఎక్కడ యూజ్ చేస్తాం, వి యూజ్ ద ఎన్ ఫ్యాక్టర్ ఇన్ డినామినేటర్స్. సో దాన్ని బేస్ చేసుకొని వీఆర్ ఏబుల్ టు రైట్ ఎ స్టెప్ దట్ see the milli equivalents of MnO4 minus exactly equal to milli equivalents of oxalate. Okay, so just we are taking as a 1 milli equivalent, so both are equal but we know the exact value, but we are taking as a 1 equivalent. So milli equivalent but automatically equivalents are also become equal, just we are taking as 1 equivalent. So 1 equivalent when compared into moles, మనం mole factor moles లో compare చేస్తే so equivalent equal మనం so moles equal to 1 equivalent by equivalents by n factor. So here therefore what is the how many moles? 1 equivalent by what is n factor for MnO4? 1 by 5. So it changes into moles. Here also 1. What is n factor? 2. Means here 1 by 5 moles of MnO4 minus reacts with 1 by 2 moles of C2O4 minus 2. So what is the problem? So 1 mole of C2O4 minus required how much? So here we can write a step that with the help of this we can write 1 by 2 moles of C2O4 minus 2 required 1 by 5 moles of MnO4 minus. Then what about 1 mole? 1 mole of C2O4 need how much MnO4 minus? So finally we'll get and how much it is 1 by 2 into so 1 by 5 total we get 2 by 5 mole. Just on cross multiplication we will get it. Okay, so tomorrow we see some more problems based on this, but you have to practice because just we are giving 4 to 5 problems per day. Just spend half an hour, 20 to 30 minutes to practice it.